Hi everyone, Krishna this side, and in this video I'll cover the topological sort using DFS approach. In the last video I covered it using breadth first search, but in this video I'll cover it with the help of depth first search. Okay, so let me just remove the previous code, but I'll keep the Arson list as it is because I don't want to rewrite the code again. But it is pretty much simple. We have this edge graph. Based on that, I just created the Arson list, which will be storing the Arson nodes for each of those vertices. Okay. Uh, so yeah, since we are using the DFS, so definitely whenever we work with the DFS, we use stack as a data structure to store any nodes or vertices, and that is something first thing that comes into our mind. Now how we approach to this one, right? So see, let's go through this particular example. As we are using the DFS, so any particular vertices will even if it got visited, right, from 5 0 already got visited, but still from 4, as we start looping and using this DFS algo again and again, so this 0 in the recursion we may revisit again, right? So since it is already visited, so we shouldn't be visit it again. So for that we need to have a visited array in our bucket. So what we basically need is a visited array which will store if that is visited or not. That is the first thing. Stack is something what we need to get the data, and that I'll explain you like how the stack will be going to work in this particular algorithm. And next thing is yeah, I guess that is pretty much all. We just need to have the understanding of recursion, how things works in the recursion. Okay, so in the visited array, let us suppose we have this 0, 1. For 0, from the same example, with this same example, I am just writing that 0 from 0. Is there any node that is is there any edges that is going away? There is no, right? So the array list is going to be empty for the 0. For 1, yeah, it is having 3 as argent node. For 2, is there any? Yeah, 3 is having argent node. And for 3, what is the argent node for 3? Nothing, right? So it will be null. For 4, it is going to be 0 and 1, 0 comma 1. And for 5, it is going to be uh, 0 and 2. Okay, this is what the arson list that I have created at here. And now what how we can process it, right? So we can start from the 0 or any node, but since they have given from 0, so we can write the code based from the starting of 0. So what I'll create is I'll start from the 0, and I'll explore all the vertices that we have, and based on this particular one, what I'll do is I'll call the DFS. But before calling the DFS, what we can make sure is we will be having a visited array, and inside this visited array I'll store the vertices, and with these vertices, right, we check that if vertices this particular vertex is having 0 or not. That means whether it is visited or not. By default this will store 0 values, right? So definitely we check that if this particular current vertices if visited or not. So that simple check we will add, and we call the DFS, and inside DFS we will pass visited, stack, current, and the ADJ. So current is nothing but here it will be I, that vertex that we have. Okay, now we will implement the DFS algo, and I'll explain you guys as well like how this basically works. So public void, it is not writing anything, so void DFS int vs stack, and then int current, and then uh, array list of ADJ. Okay, ADJ, sorry, it shouldn't be ADJ, it should be integer. Okay, let me put this down. Now how recursive works, right? So the moment we call the DFS, now inside this we will be working with the recursive approaches. Okay, So by default, zeroth node is definitely it is not visited. So what we do is, first thing is, we will make sure that this current is being visited. So we mark it as 1. Okay. What next? We start exploring its adjacent nodes. Okay. So what are the adjacent nodes for this current one? ADJ node for this. From this adjacent list, we get this adjacent node for this current one. And we check that if visited of ADJ node, if this is 0, then only we will call the DFS one, because there is no point if that is been visited and again we want to call the DFS, right? So that there is no point calling that. So we make sure that if it is not visited, then only we call the DFS. Okay, so we pass visit, and what is this? Why I write type of code? Stack, and for instead of current, now we pass this adjacent node, and ADJ is what we need to pass. Now how this works is, for 0 there is nothing, so simply we at the end we use this stack to push that data. So we push the current. Now in the stack, 0 is already available at the bottom. Okay, now we start exploring for 1. So uh, the moment we see here, if condition for 1, it is again 0, so we go into this DFS. In DFS, visited of current is going to be 1, so we mark it as visited, and we look for this for loop. We check if there are any adjacent node for this one. Yes, there is 3 which is adjacent to this one, right? So we check that if whether this 3 is visited or not. So if it is not visited, again we call the DFS, and we pass visited stack and adjacent node this current 3. Okay, now 3 is been invoked, this DFS again gets called, and we mark that 3 as visited now. And we again check for 3 if there are any adjacent node that are there. For 3 there are no adjacent nodes, so we simply push this into the stack. Now in the stack, how the stack is looking is, initially it was having 0, and we know that how the stack works is, it is kind of LIFO, last come gets out as a first, right? uh, so I don't know like how, what we call LIFO or FIFO, I don't know. Let it be, whatever the element is been added at last will get out at the first. Okay, that is LIFO only, last in first out. Okay, so 0 is been added into the stack. Now what is been added? 3 is getting added. After 3, uh, once 3 is finished its task, it returns back to again here. Okay, it returns back to here when we 3 has been called from 1, right? So again it returns back to 1, and now this particular function finishes its task, because for 1 there are no any addition note extra that are there. So it simply finishes its task, and we push this one into the stack. So now stack looks like this. Okay, now what next? We are checking for 2, right? 0 is been explored, 1 is been explored. Now we are checking for 2. 2 is not visited, it is 0 by default, so we again call DFS. Now visited for the 2 is going to be set to 1, and for what are the adjacent nodes for 2? It is 3, right? But 3 is already marked as 1 from this one, right? So this will not get invoked, and simply we put this 2 into the stack. Okay, so 2 is been added into the stack. Now what next? 3 is being invoked, but 3 is already visited, so we are not going to visit the 3 further. What else? I is going to be 4. Now we check visited of 4 is been there or not. So it is not there, so we didn't explore 4. So we go into this one, and we call the DFS, and again we mark it as visited. The 4 is been visited now. The we check for the adjacent for the 4. What are the adjacent nodes for the 4? They are 0 and 1, right? So we check for the 0, but 0 is again this DFS calls. But before that, we check if it is visited or not. So visited of 0 is been already there, right? So we don't go inside this one. Again we check for 1, but 1 is already visited, so we are not bothering again. So all the nodes that are there adjacent to this 4, those are all already visited, so we are not going inside this one. But 4 will be putting in inside the stack. Okay, so simply that has been done. Now remaining one is 5, but for 5 again it marks at visited, and we go again, we check if they are visited or not. So all the adjacent nodes are already visited, so we are not going and calling them recursively, and we simply push this 5 into the stack. So that's how things works, and this is the answer, final answer from the stack. We need to keep on popping them, and we return them into the answer. So we are supposed to return the array list, right? So list is my answer, and what I'll do is I'll simply uh, pop the element from the stack, right? So stack is not empty. List dot add stack dot pop. Okay, and just return this list. Okay, I hope I haven't made any mistakes. Let me compile it. Okay, multiple errors. Cannot find symbol visit. Line number 73. Okay, DFS. Why? Variable stack. Did we not define stack? Okay, sorry for that biggest blunder that I have done here. Let me create the stack here. New stack. Okay, stack has been created while stack is not empty. Okay, all are based out of stacks only. So stack has been created there, right? Okay, that was the mistake. Okay, so it is returning true. So okay, what non-static method? Okay, okay. Is it static? Oh, sorry. Yeah, this should be static, and I guess that should be the last error we have here. Let's compile. It is returning true. Let me submit the code because I'm just bothering for one particular issue here. So it get passed. That is well and good. But there is going to be problem with this particular code, and I'll explain you where. Okay. See, this basically works if there is no cycle. Okay, this is working fine now, and I guess all the submissions are working fine. See, what I'm trying to say is this basically works fine, but if at any point in time, if there is any cycle in a graph, okay, and we use this particular algorithm, there also it try to give us the answer, because we are not checking if there is any cycle available in a graph or not. But with the help of BFS algorithm, there we are relying on the in degree. So at any point in time, we are not going to get any in degree as zero. So the cycle detection, whatever is going to be there, it will handle with the BFS. But with the help of DFS, it is not going to handle that situation. Okay. So we need to make sure that we we are not having any cycle in a graph. We are not running in a cycle. So some simple minor changes that needs to be done into this particular piece of code. But the cycle detection, that I'll cover it in another video. So if you guys get that idea, or you guys want to explore here also, you guys can update this part of code. Okay. So we should create another visited I mean current visit kind of thing, and we should check that if that has been visited in current loop or not. That is something what we need to check, and we need to make sure that there is no cycle in a graph. But this basically write the code if at all, if there is any cycle or not, no matter what is the graph, it will return the answer. So that is something wrong, but this is getting accepted, so I didn't bother with that. But yeah, that's all from this video, and I'll cover that one. Okay, so thank you for watching this video. Bye bye.